Well, good morning. I hope this finds you well. This is Ms. Billerbeck, and we're going to do a quick review of what you learned last week. So we talked about points, lines, and planes. So points land in one particular spot, a location, and it doesn't have any dimensions. Then we have a line, and the minimum points for a line is 2. So any line can be defined by 2 different points at minimum. Then we have a ray. A ray has a vertex, and then it goes on forever in one direction. And a plane is like a piece of paper, and it takes 3 points minimum to define a plane. So let's look at the types of angles. So we have a right angle. We have the reflex angle, which is on the outside. We have an obtuse angle. If you remember, ob means very large, like obese. And then the same root means large. So obtuse angle means the big angle. It's greater than 90 degrees. Acute angle, you could think of, it's a cute little angle. It's less than 90 degrees. Then we have adjacent angles. Adjacent means next to. So we have one shared side between the adjacent angles. Now let's look at some special angles here. We have complementary and supplementary. Complementary, now this isn't you're wearing a nice hat today. This is more like your red shirt really complements your dentist khaki pants. So complement has an E here instead of an I. So it means they work together to make 90 degrees. Now they can be adjacent, or they can be just 2 different angles that add up to 90 degrees. This picture is showing 2 adjacent angles that add up to 90 degrees. When we see this M here, if you remember, it means the measure of angle A plus the measure of angle B equals 90 degrees. So whenever we use an M with an angle, this is a number instead of a thing. Without the M, it's angle A, kind of like I'm Miss Billerbeck. But my measure is, sadly, 5'2". So on supplementary angles, we have a straight line in this case, and they're 2 adjacent angles. They're sharing a side, and we have angles C and D. So we have the measure of angle C plus the measure of angle D equals 180. Adjacent angles are on a straight line. They would all add up to 180 degrees. So in this case, with angle A, angle B, and angle C, we have the measure of angle A, the measure plus the measure of angle B plus the measure of angle C equals 180 degrees. Now, if we have a circle, oops, there we go. We have angles that are formed from a point. We have angles on all sides of this point, but there's a circle that goes around. So when you're doing skateboarding, a half circle or a half turn is 180 degrees. But when you're doing a full turn, either in dance or skateboarding or skiing or snowboarding, it's a 360-degree full turn. Okay, and then as you do double turns and all that, it keeps adding up to the degrees keep getting larger and larger. So if we have A, B, and C, and D, we would take the measure of angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D, and that's going to equal 360 degrees because they all make a circle when you add them up. We also have special cases over here with vertical angles. Okay, vertical angles, they're like bow tie angles. Okay, so if we have vertical angles, no matter how we make the angle, the opposite angles are always equal. Okay, so opposite angles are always equal. So A would be equal to B. So we would say the measure of angle A equals the measure of angle B. They're vertical or opposite angles. Okay, so we drew perpendicular bisectors on Wednesday. When we did that, we looked at the word bisect. So bisect, bi means to, sect means cut. So we make a cut and we cut it in two. So this is equal to that. And it's perpendicular, so we have a right angle right there. So that's what makes it a perpendicular bisector. So we didn't talk about that this line would be congruent to that line, but that is also true. And this right angle here is called the foot of the perpendicular. So there are certain properties that come up with a perpendicular bisector. So we have lines, the measure of line segment AP equals the measure of line segment BP. If you notice there's no bar over this AP and BP, that's because we're talking about the measure of the line segment AP equaling the measure of the line segment BP. As soon as we put that bar over it, it again becomes a thing. So it's more like Ms. Billerbeck when you put a bar over it instead of the measure of Ms. Billerbeck. So no bar means the measure of. Okay, so AM is right here. So the measure of line segment AM equals the measure of line segment BM. So that would be right here. So this is the bisected segment, the perpendicularly bisected segment. Now we have the measure of AMP, the measure of angle AMP equals the measure of angle BMP. And those equal 90 degrees because if this is 90 degrees and the whole thing together is supplementary, it adds up to 180 degrees. Well, what's 180 degrees minus 90 degrees? That's right, 90 degrees. So if this is 90 degrees, that's 90 degrees. That's 90 degrees. That's 90 degrees. And if that's 90 degrees, that's 90 degrees. So if we have intersecting lines and we just have one of the vertical angles or adjacent angles marked as a 90-degree angle, that means all the other three angles are 90-degree angles. Kind of cool. So let's look at angle bisectors. So we also made angle bisectors on Wednesday using MathPad construction tools. That is an online website. So, and if you forgot what website that was, it's MathPad, MathPad construction tools. So on this one, the angle bisector, again, we're going to cut it, sect, and two. So we have one angle, angle BAC, and note in the middle is the vertex of the angle right here. Okay, so that's where you put them. The middle letter is always the vertex of the angle. So we have BAZ, oh, that's right here, equals the measure of CAZ. So what that's saying is this little angle here equals that little angle there. All right, and there's a special quality when we do an angle bisector. It's if we draw a perpendicular from the side of the angle and intersect it at C, the perpendicular from the other side of the angle, and when it intersects with Z, happens to be the same length. Another very cool fact about angle bisectors. All right, so that concludes our review on our properties of points, lines, planes, and angles. Hope you have a wonderful day, and look out for section 8.2 coming up next. Bye.